Hello there, it's Jason Gorman from Codemanship with another video in our series on codecraft for Java developers. In this video we're going to be looking at the discipline of refactoring. Refactoring is improving the internal design of software without changing what it does, specifically improving our code to make it easier to change, to make it easier to understand, to remove duplication, to simplify the code, and to tackle any problem dependencies. Now, refactoring is a very, very important discipline. It's often thought of because it sort of dates from around the same time as extreme programming in terms of the name of this practice. It's often associated with agile software development, but in reality, if you're doing any kind of programming, it's an essential skill. And it's a term that is very often used and very often abused. And in reality, a lot of developers, most I would say in my experience, don't have any real experience of refactoring in the strict sense of the word. So what we're going to be doing in this video is I'm going to be demonstrating the refactoring discipline, or rather demonstrating the way I do it, using this Java example. And hopefully you'll get a feel for how this practice works and how you might apply it to your own code. Now, the idea behind refactoring is if we take a look at our Mars rover code here, we've got a Mars rover that allows us to drive a rover over an idealized grid of XY coordinates that represent the surface of Mars. We can send our Mars rover sequences of instructions, F for forward, B for back, L for turn left, R for turn right, and it will execute these instructions for us. So it's a relatively simple piece of code, and it all works. It's got tests. We'll talk about tests in a minute. But if we take a look at this code, well, yeah, it's got what we call code smells. These are signs of increasing entropy in the code, that the code is rotting. And if it's not tackled, if we don't refactor this code to simplify and remove these code smells, in this case, if we take a look at our go method on our rover, it's very long and there's lots of duplication and nasty nested if statements and all that kind of stuff. If we don't tackle these code smells, if we don't refactor the code, what's going to happen here is that this code is going to become difficult to change and it's going to become easy to break. It's going to become rigid and brittle. So over time, as our software grows, as the code grows and evolves, without fairly continuous refactoring, we end up in a situation where the cost and the risk of changing code gets steeper and steeper and steeper until it's too expensive and too risky to change. So even though this is a low-level coding practice, and is often thought of in those terms, for example, by managers, but by many teams of developers as well, in reality, it's a discipline that's essential if you want to remain responsive to change. If we want to change what the code does, we need to be able to change the code easily and safely without breaking it, basically. And that's what the refactoring discipline is all about. It's about restructuring the code internally to make it easier to change without breaking it. Now, before I start refactoring this go method, nasty though it is, we need to think about safety. Refactoring is all about safety, and it achieves safety in three ways, as we'll see. The first way that refactoring achieves safety, prevents us from breaking our code, is through tests, automated tests. So I have a pretty comprehensive suite of JUnit tests here, 17 of them in total. And before I do anything to this code, the first thing I'm going to do is I'm going to make sure that my tests pass. There we are. Let's just rerun all of our tests. And as we do this refactoring, as we clean up this go method, I'm going to be running those tests very frequently so that I can get immediate feedback if the code is broken. And if I break the code, I can easily undo that or I can fix it straight away. So that's the first part of our safety net. Make sure your tests are passing, and we're going to keep those tests passing as we refactor this code. The second part of our safety net, if you like, is version control. We need to be able to get back easily to working code. So if we mess up, if we make a boo-boo, it needs to be easy to get back to a working version. And also, if we end up in a situation where we've refactored the code and we don't like the design that we've come to, we might want to go back to a version of the code that works and has a design that we were last happy with. So version control is basically its seatbelts for programmers. It's very, very important. So before I do any refactoring, I'm just going to check that I'm all up to date in my local Git repository. So I'm going to attempt to do a commit, and hopefully it will tell me that I'm all up to date. So seatbelt on for refactoring, and hopefully it'll tell me there are no changes to commit. There we go, our branch is up to date. If I'm doing continuous integration, of course, I will be committing and pushing this to the master branch, but that's a video for a later date. So make sure you've got tests. If you don't have tests, write them. But don't just take the test word for it either. Just because the tests are passing, particularly if they're tests that you didn't write, if you inherit this piece of code, for example, then you might want to test your tests and do what we call mutation testing. So you might want to deliberately introduce some bugs into the code so that you can run the tests and make sure that when the code is wrong, the tests do fail. And for Java, there are several mutation testing tools that will help you basically gauge how much faith you should be putting in those tests by mutating the code that you're going to refactor. So tests, very important. Version control is seatbelts. So if we have a little bit of a crash, a bit of a ding, we can easily get back to working code or a version of the design that we were happy with. And the final sort of safety aspect of refactoring is the size of the changes that we make. And this is what I'm going to demonstrate. So tests are passing. We're all up to date with version control. We're ready to do our first refactoring. Now, refactoring is both a verb, I am refactoring, you are refactoring, she is refactoring, they are refactoring, but it's also a noun. There are such things as refactorings, and these are small atomic rewrites of the code. For example, if I wanted to rename this class from Rover to Mars Rover, the complete refactoring, the complete step, would not just be to change the name here, because if I do that, as you'll see, it breaks a bunch of stuff. It's broken the constructor, and it will have broken most of our tests as well. As we see now, they're all wrong because it doesn't know what the Rover class is. It's gone. So to do it as a complete step, we can't just rename the class. We have to, let's just undo that. We have to rename the class and update all of the references to the class, and that's a complete refactoring. At the end of every single refactoring, the code should still work. We say that each of these refactorings is behavior preserving, doesn't break the code. So they're like atomic rewrites of the code. Think of them as transactions against your code, and they either work or they must succeed as a whole. You can't do half of rename because then your code won't work. And at the end of that, each of these refactorings, we prove that our code works by rerunning the tests. Now, refactorings are like the moves of chess. They each have their own name, like rename a class, extract methods, inline parameter, etc., etc. You're going to see me do some of these. They're a bit like the moves of chess or the moves of jiu-jitsu, and they have very well-defined mechanics as to how they rewrite the code, such that at the end we've achieved our refactoring goal and the code still works. And I'm going to do my first refactoring manually just to demonstrate what I mean by that. So we're taking a look inside of this long, complicated Go method. Let's make a bit more space here. And what we can do to break down this long method is we can chunk it up into smaller helper methods so that our Go method will use these helper methods instead of doing all of the work itself. For example, this block of code here, what does this do? Well, it turns the rover to the right. So if it's facing north, it'll end up facing east. If it's facing east, it'll end up facing south, and so on. So what we could do is we could extract it into its own method. I'm going to do this manually. So I'm going to cut this code and I'm going to replace it with the call to this new method that I want to create. And let's do that now. Let's create that method. And I'm going to paste the code in. It's a nice simple one, this. And that is a complete extract method refactoring. That's the name of that refactoring, extract method. So let me just clean that up a little. And as soon as I've done that refactoring, what I'm going to do is immediately rerun my tests and make sure that they all still pass. All green. Lovely. So that means that we're good to go, except we need to put our seatbelts on. So having done that refactoring, so that in case I mess up the next one, I can easily get back to here to working code, I'm going to commit this to my local repository. And what we've done is we've extracted a write method from rover.go. So this allows me to get back to here if anything goes wrong downstream. And off we go. So tests are passing. The seatbelts are on. We're safe to do another refactoring. Well, let's carry on breaking down this go method here. I'm going to do another one. Now, you'll see in a minute that I don't have to do these manually. We'll talk a little bit about automated refactorings in a second. But for now, I'm just going to rinse and repeat. So let's create this new left method for turning the rover to the left. Let's paste in the code and immediately rerun our tests. Off it goes. So again, all green, which means it's time to put our seatbelts on, just in case we mess up the next refactoring. So we extracted. So I'm choosing these. I'm naming these commit messages fairly. Oh, that's really annoying. Fairly carefully, and we'll see at the end why it's a good idea to put a little bit of effort into this. There we go. Seatbelts are on, which means we're safe to do another refactoring. Now, I don't have to do the whole cutting and pasting and whatever thing. I can actually, in IntelliJ, do this as a single step using the built-in refactoring. So let's take a look at our refactoring menu. Here's the context-sensitive version. And we've got a refactoring there called extract method. And it's going to do all of it for me. It'll take this code, cut it from here, replace it with a call to the new method, declare the new method, and paste in the new code. And it will rewire any parameters and anything else that it needs to do to make it all work in a single step. So we're going to call this forward. Nice easy one. So there we go. It spotted some duplication. There's another method that's a bit like this one, and it's thinking, oh, I can make this reusable. But oh dear, oh dear, oh dear. Doesn't that look nasty? So we're not going to accept that help. We're just going to keep the original signature and just ignore the duplication for now. Okay. And immediately rerun our tests. So that's kind of the workflow. It seems very simple, doesn't it? We do a single refactoring. We rename a class or we extract a method, and then we immediately rerun our tests. And we then put on our seatbelt. It's a good idea to have seatbelts if you're going to go for a bit of a drive. So that we are safe. We can always go back if need be, if we mess up. And finally, this block of code here moves the rover back. So I'm going to use the shortcut for extract method. There we go. Brings it up straight away. Most of these automated refactorings have their own shortcuts, so you can get to them in context very easily. And that's our back method. Again, we don't want the help there. Thank you. And immediately rerun our tests. And all our tests are green. So now our go method is looking considerably smaller. We have, at the same time as extracting these helper methods, the names of the methods have allowed us to document what each block of code does, right, left, forward, back. So there's a bit of a double win there. We're breaking down this long, complicated method, but we're also making a bit more self-describing. But there's still stuff in here that I'm not happy about. These 4 if statements, this is basically, it's a lookup basically, where we're matching a character, an instruction character, to an action. So we could make that more dynamic and get rid of these nasty ifs by actually go the whole hog. So this is going to be a map of characters to, let's make that runnable, to actions. Let's import map. Let's call that our, or we can call it actions. There we go. And what we can do is we can declare this as a map of. So let's do the mappings now. So R is for write, and we're going to map that to a call to the write method on this object with a small r JSON, because we're not in C# now. I was doing C# yesterday, so I've still got that on the brain, I'm afraid. And we'll map the L to left. So we're making it quite explicit here how these instruction characters map directly to actions. Forward, F for forward. And finally, B for back. Okay. So there we have a map of instructions to actions. And all we need to do is look up the right instruction. So instruction here will be an int. So I'm going to have to cast that to a character. That's fine. So basically, let's look up which action we're talking about. I'm going to cast that to a car so that it matches our character key of our map. And then we just execute it. Simple as that. So just run. Okay, now that should be equivalent to what we've got basically. That map and that lookup is doing the same job as these if statements, but it's much more dynamic. And again, it's made the mapping more self-describing. It's easier, I hope, to see that R is for right and L is for left and F is for forward and B is for back. So it's a double win. Let's immediately run our tests and make sure, make sure we haven't broken anything. Lovely, wow. Now, what I did there was a little adventurous. It was a little bit of a leap. But I was confident in taking that small leap because I've got my safety net, I've got my tests, and I've got version control. So if it all goes wrong, then I can easily get back to the way it was before, the last time it was working. So in a weird kind of way, the more cautious I am when I'm refactoring, the smaller the steps, the more often I back it up into version control, the more often I run the tests, and the more confidence I have in those tests, the more comfortable I feel taking some risks with the design, taking some risks like this. So in actual fact, the more cautious you are, the braver you tend to be in terms of design. So it can really pay off, but it does require a lot of discipline. You're taking those small steps, making sure you got the tests, running the tests all the time, committing frequently. So it takes some discipline, but once you've got that discipline, you're in a very good position to take some risks with the design. Okay, now there's one more thing here. So this is the code that executes the instruction. I'm thinking maybe I could make that more explicit. So have one method that is about the lookup and another method that is about executing the instructions in a loop, as it were. So what I'm going to do is I'm going to extract this into its own method. Let's call it execute. And there we go. Let's immediately rerun those tests. So the go method now is very, very small. It hopefully is relatively self-describing. For each of the characters in our instructions, I want you to execute that instruction. And then we've got another method here that basically looks up the instruction and executes it. So that's all good. So there's more stuff we can do here. Let's, now that we've done that, put our seatbelts on. So we replaced. So the name of this refactoring is called replace conditional with polymorphism. Because right, left, forward, and back all have identical signatures, we've essentially gone away from using these if statements, say if it's this, do this, if it's this, do this, to a polymorphic solution that has a lookup here, so a sort of a map of actions. So we replaced conditionals in Go with, let's call it an action lookup. Okay. So again, I'm happy. Whenever you're happy with the design, that's a good time to commit it. And I think we can maybe do one more kind of refactoring here. There's lots to do on this code, but I think we'll demonstrate one more. We'll take a look at the left and the right methods here. Again, there's those nasty if statements, some duplication going on here. We might be able to do something, again, that's kind of dynamic. Well, if we're facing north, we go east. If we're facing east, we go south. If we're facing south, we go west. And if we're west, we go north. So if you imagine we kind of have a compass, we're just going clockwise to the next direction in the compass. So could we represent that as, for example, an array of directions? Let's call that our compass. And if we're going right, we're going clockwise, so north, east, south, west. So far, so good. And what we're going to do here is we're going to look up where we're currently facing in that compass. So what's the index of that? So if we do it as a list, we can use index of to find out what's the index of the current direction in the compass. And what we're going to do basically is we're going to add one to that. So if your index is 0, that means you're facing north, then we'll add 1, so you'll be facing east, which has an index of 1. So it's current plus 1 now. There should be an equals there. Now, that's going to work for north, east, and south. But when we get to west, which has an index of 3, if we add 1 to that, we're going to get an index out of bounds error. So we need to go back to the beginning. If the index becomes 4, we need to go back to 0. A simple way of doing that, I think, might be to use modular. So if we do current plus 1 mod 4, so if current is 3 and we add 1, mod 4 is 0, so that takes us back to the beginning. So we go around the compass again. Okay, let's get rid of all that redundant nasty if statements. And immediately let's rerun our tests. Okay, so far so good. Now the only difference between turning left and turning right is the direction the compass is turning, whether you're going clockwise or anti-clockwise. This would be the same. Well, the only thing that would be different is whether it's northeast, southwest, or northwest, southeast. So if we extract this into its own method, let's call that a turn. And turn takes a compass. Let's just rerun our tests. Okay. And I can inline that. So we don't need that local variable anymore. Rerun our tests. So rerunning the tests over and over and over again. Keep it working. Keep it working. Do not step too far from working code. And now we can reuse that turn method in our left method, just with a different oriented compass. So northwest, southeast. So we're really starting to break this down now, and we're introducing a lot of the words that we would use to describe this problem: left, right, forward, back, move, turn, compass, etc. We've been introducing these words to make the code more self-describing, as well as simplifying the code and removing duplication. So we're well on the way here. There's more refactoring to do, but I'm aware of the fact that I've already taken up a lot of your time. So I will carry on in my own time. We'll draw a line under it here. So the important things to remember with refactoring are: number one, refactoring is improving the internal design of code to make it easier to change. So let's make it easier to understand, removing duplication, simplifying the code, and dealing with problem dependencies. So improving the internal design to make it easier to change without changing what the software does. In other words, to clean the code without breaking it. Safety, 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 very, very important. The three aspects of safety and refactoring that are most important are tests. You need good tests. You need to be running them very frequently after every refactoring. Version control, or the ability to undo or to step back to working code, is very, very handy. The number of times that has saved my bacon. So put your seatbelts on using version control. And finally, we do it in these baby steps. So we do a refactoring, we run the tests, and if we're happy with the design, we commit that, and then we do another refactoring, run the tests and commit that, do another refactoring, run the tests and commit that. So we work in these baby steps. By doing that, we don't step far from working code. It's very easy to keep the code working or to get back to working code. And that actually allows us to be a bit more adventurous, to experiment a bit more with the design. So in a weird kind of way, being more cautious makes you braver. That's the refactoring discipline. The last thing I want to show you, though, just about these Git commits that I've been doing. If I were to bring up my Git log, so look at my commit history here. Let's take a look at that. We've got, it reads almost like a kind of an undo history. It's an interesting history of all the changes I've just made to the code in terms of the refactorings I've been doing. And I find these jolly useful for all sorts of reasons. First of all, it's easy to identify, okay, well, if I need to go back to that point, then I can go back there. But also, often when I'm working with teams and they're asking me to look at their code, I won't just look at the code the way it is. I will actually go back through the version history of the code, look at the changes they've made, for example, look at the refactorings they've done. And this documents the kinds of decisions that they're making. And it's very easy, for example, to see teams that don't do very much refactoring because they have very few of these. Now, at some point, I'm going to push this to the remote repository so that the other members of the team can see the changes I'm making. Here's one last piece of advice. If you're working on a team and you're refactoring, you need to push, not as frequently as I've been committing, but still relatively frequently. You need to be doing real continuous integration, not pushing to your own branch or etc., but actually merging to the master branch so you can share your changes with the rest of the team on a frequent basis. Because if you don't do that, the danger is that you'll do a whole ton of refactorings, completely restructure the software, completely change the structure of the code base, and then you'll spring all those changes on the team in one go. And I've lost count of the number of times when I've been working on a team and someone has basically done 3 or 4 days of refactoring, and they've moved stuff around and deleted folders and done all sorts of stuff at a high level, and then they push all those changes in one go, and it's a complete train wreck, basically. We're all working on stuff that doesn't exist or has been renamed or has been moved. So don't do that. Drip feed your changes as you refactor to the rest of the team. Okay, so that is the refactoring discipline. In the bonus video, in the next video, I'm going to be taking a look at our refactoring menu, of which there are many automated refactorings in IntelliJ. So if you're not an IntelliJ user, you might find this interesting. Or if you are an IntelliJ user, but you're one of the many IntelliJ users that really isn't very familiar with these automated refactorings, then you might find this useful.